Hello class, welcome to Pre-Algebra Lesson 3.3, which is all about understanding proportional relationships and equivalent ratios, okay? Or more specifically, equivalent ratios. Okay, so by the end of this lesson, you should be able to test for equivalent ratios to determine whether quantities are in a proportional relationship. So this slide right here has a lot of mathematical vocabulary. So let's just quickly recap a couple of things. So equivalent, remember, means the same or equal. Ratios, those occur when you compare numbers to each other or different quantities to each other. And then proportional means that it's always changing by the same amount. Okay, and let's take a look at some examples of these. So being able to recognize a proportional relationship. So we have on Sarah's favorite mobile game, she is awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Explain. Okay, so here we have three different screenshots from her cell phone. So you can see in this first screenshot, there are 3 gold coins, and beneath each gold coin, there are 3 hearts. So notice that there are 3 hearts beneath each of them. And then if I look at this second screenshot, I have 2 gold coins, and again, there are still 3 hearts under each coin. And for this last screenshot, we have 5 gold coins, and again, there are 3 hearts under each of them. So if I were to talk about this using mathematical vocabulary, this is kind of what I would say. These 2 quantities, and the 2 quantities are the gold coins and the hearts, okay? These 2 quantities are in a proportional relationship if all of the ratios that relate the quantities are equivalent, okay? So basically it's saying every time there's a gold coin, is it consistently that she is awarded 3 red hearts? And the answer is yes, because if you look at this, when she had 3 coins, she was awarded 9 lives or 9 hearts. When she had 2 coins, she was awarded 6. When she had 5 coins, she had 15. Okay? And the way that you would write this out in order to be a ratio is a very common way is to write it as a fraction. So you can see for this one, it would be 3 over 9. And here is where you can tell if things are going to be equivalent. I'm giving you a little preview to our next example too, okay? So if I were to take all of these fractions, all of those relationships that she found, because this is proportional, it's always going to be 3 lives for every coin, okay? So if I were to simplify this fraction, I know that 3 over 9, the simplified version is 1 over 3. And then if I were to look at 2 over 6, again, the simplified version of that fraction is 1 over 3. If I look at 5 over 15, the simplified version of that fraction is 1 over 3. So all of these would be considered equivalent ratios, okay? So that's kind of what we're going to be doing all throughout this lesson. So what I want you guys to do is take a couple of minutes to look at this table and see if you can fill it in. So we have Miles records the time it takes to download a variety of file types. How is the download time related to that file size? Explain. Okay, so you can see here that for a document, the file size is 1.25 megabytes and the download time is 25 seconds. Okay, and then here it tells you that download time number goes on top and it's being divided by the file size. Okay, so then you put the file size right here. Then for a song, 3.6 megabytes takes 72 seconds to download. So again, you fill in the box, and then the last one's video. It's 6.25 megabytes. Download time is 125 seconds. So then you would divide those out to see what you get. So go ahead, take a minute, and fill in this table, those 3 boxes, and see, are all of these equivalent? Okay, do they all end up being equal to the same thing? Good luck. All right, for this problem, hopefully your table got filled in looking just like mine. And if we were to kind of explain this, our explanation for this problem would be that the ratios are equivalent, okay, meaning they are the same. So that means that the download time and the file size, they are proportional to one another. And the reason I know that is they are all equal to 20 when you divide them, okay? Now, example 2, we want to determine whether quantities are proportional. So our question is the relationship between the area and the side length of the squares proportional? Explain. So we have 3 squares here. We have a square that has 2-inch sides, a square that has 3-inch sides, and a square that has 4-inch sides. So our side length is 2, 3, and 4. So then the area of the squares, we would just say like 2 times 2, right? That's 4. 3 times 3, that's 9. 4 times 4, that's 16. Excuse me. So if we were to write out our proportion, it would be area divided by side length. So you can see I would have 4 over 2, 9 over 3, and 16 over 4. If I were to simplify those, do you see how the 4 over 2, that becomes a 2 over 1, the 9 over 3 becomes a 3 over 1, and the 16 over 4 becomes a 4 over 1. So that means that these are not proportional. And the reason we would say is because they don't equal each other. In order to be proportional, the relationship has to be equivalent. So it means that like one way of looking at this is here, this is like 2 times 2. In order for these to be proportional for the next 2, you would have to multiply them by 2 rather than multiplying by 3 or 4. Okay, you always have to multiply by the same amount in order for it to stay as a proportional relationship. Okay, so I want you to take a look at this one. We have the table shows the side lengths and perimeters of regular hexagons. Just a reminder, regular means all of the sides are equal. And then hexagon means that there are 6 sides. Okay, so the table shows the side lengths and perimeters of regular hexagons. Is the relationship between the perimeter, so the distance around the outside, and the side length of the hexagons proportional? Explain. So you have these 2 quantities right here. Go ahead and set up some fractions and determine, are these proportional? Good luck. All right, for this problem, hopefully you said yes, they are in fact proportional because the ratios are both equivalent to 6 over 1, right? If I were to do 12 divided by 2, that's 6 over 1. If I were to do 18 divided by 3, that's 6 over 1. So that tells me that these are proportional relationships. Then we are going to look at our last example for today, and then you'll have a question to try just like this. We want to use proportions to solve problems. A proportion is an equation that represents equal ratios. Use the table, I guess, below. How many times will a hummingbird beat its wings in 60 seconds? So right now you can see we have every 2 seconds a hummingbird beats its wings 160 seconds. In 7 seconds it has 560 wing beats. In 10 seconds it has 800 wing beats. So the first thing we want to do is confirm, is this actually a proportional relationship? So if I were to check that, I would take my wing beats and divide by the number of seconds. So 160 over 2, that's going to be 80 over 1. If I were to take 560 and divide by 7, that's going to be 80 over 1. And you can use a calculator on this, okay? If I have 800 over 10, again, that's going to equal 80 over 1. So since these are all equal, I know it is proportional. Okay, so now what I can do is, this is 80 beats per 1 second. Okay, so 80 beats per 1 second. I have two different ways that I can solve this. So I could say 80 beats per 1 second, and I could just say times 60 seconds equals the number of wing beats, right? And if I were to do that, this is like a 60 over 1, right? So I could say 80 times 60, that's 4,800 or 4,800 over 1. And that's probably, if you guys were told to solve it on your own, that's probably how you would find your answer. I'm going to introduce you to something that might be new for you. It also might not. But this is the method I want you to start practicing, because it's going to have a lot of applications as you move forward in math, okay? So what you're going to do is to set up a proportion. You can take the 80 over 1, and you're going to say equals, and then 80 represents wing beats, right? I'm going to just put a Y there because I want to know how many wing beats this hummingbird has in 60 seconds. So this is how you would set up your proportion. And with a proportion, you're going to hear me say a phrase over and over. Okay? I'm going to say cross multiply and divide. So what that means and what that looks like. So the cross multiply step is where you take the two numbers and you multiply them together. So this is the cross multiply. Okay? And when I do that, 80 times 60, that's 4,800. You write it over 1. In this case, because that's the number that's on the bottom. And then divide. What is 4,800 divided by 1? That's just going to be 4,800 wing beats. Okay, so that's how you could solve it using a proportion. Now, another common question I get asked is, do you have to actually solve it down to the 80 over 1 before you do this? And the answer is no. I could use any of these to find my answer. Okay, so let's say I wanted to use the 7 over 5, or sorry, the 560 over 7, and say I want to know how many are in 60 seconds. Okay, so it would look like this. And what I would do is I would say, what is 560 times 60? Because I would cross multiply. So that's going to be 33,600 over 7 equals y. And then if I were to do the division step, I would say 33,600 divided by 7. That is 4,800 wing beats. So that's why learning this cross multiply and divide process can be really helpful, because then you don't have to do an additional step of determining are they all proportional, because usually we will just tell you if it's proportional in a problem like this. All right, last question. This one's for you to solve. Okay, we have Ginny's favorite cookie recipe requires 1.5 cups of sugar to make 24 cookies. How much sugar does Ginny need to make 36 of these cookies? Okay, so go ahead, set up your proportion and solve. Don't forget to use your calculator, okay? Good luck. All right, for this problem, hopefully your work looks something like mine, and you ended up with 2¼ cups sugar is what's needed to make 36 of these cookies. If you have any questions about this problem, please be sure to reach out for some help. I'm happy to help you. And then here is just a little key concept to help summarize everything that we have done in today's lesson. If you have questions about this or anything else from the video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.